Explorers looking for signs of life on Mars find some interesting new evidence. Rolling boulders indicating perhaps a Marsquake, their version of an earthquake. Joining us now to explain, former NASA astronaut, planetary scientist as well, Tom Jones, author of the book Planetology and a Fox News contributor. So why does an earthquake, or a Marsquake I should say, why does that indicate the possibility of life on Mars?
It's some great scientific sleuthing going on here, John. The scientists, using a powerful camera aboard a Mars orbiter called the Reconnaissance Orbiter there, looked at these boulders near a fault system near a big volcano on Mars called Elysium Mons. And they found tracks behind these boulders, as if you rolled a snowball downhill through the snow. You can see the track, the groove in the dust on Mars that indicates these boulders moved recently. Then they compared that to an earthquake in Italy in 2009 and saw the same pattern of landslides and boulder motion. So they deduced from the pattern of boulder tracks and the large amount of rocks moved in this vicinity on Mars that there was a recent Marsquake there.
And that indicates life. Why? I mean...
Okay, chapter 2. Yeah, if you've got a Marsquake, it has to be caused by probably the movement of molten rock within the crust of Mars. There's this large nearby volcano over 10 miles high there. So if that volcano still has moving molten rock under the surface, that raises the temperatures underneath the surface, probably melting the ice that we do know is there from other orbital and reconnaissance missions. And that molten water, that liquid water, is the perfect environment beneath the surface to host life. So it increases the chance that we'll find the environment that's necessary for life on Mars.
There was some thought that those boulders might have just been frozen in place, and because of some heating or something on the surface, they just simply, the ice let go and off they went.
True, that's one explanation, but they looked over about a 200-mile wide area across this fault system, and it looks like the range of boulders, ranging from sizes like 6 feet all the way up to 60 feet across, means that ice wouldn't be releasing all of these random sizes of rocks at once.
Interesting.
So that random size range was the clue.
Interesting detective work. Always love that stuff. Tom Jones, thank you.